My name is Nicole Emerson, and I'm joined today by Patrick Colley and Humberto Soto, who are industry process consultants within the GEOVIA brand. The topic for today is strategic mine planning for underground mines.
Good day and welcome. I would like to thank everyone for attending Dassault Systèmes' technical webinar series, where today we'll be discussing strategic mine planning. Before we begin, I'd like to take a moment to introduce myself. My name is Patrick Colley, and I am a member of the GEOVIA Industry Process Consulting team. I am a mining engineer with over 8 years of experience, and I'm an experienced user of the GEOVIA portfolio. In my current role, my focus is on helping mining customers with their digital transformation journeys using Dassault Systèmes' value engagement process. Before we jump into the topic of today's webinar, I just wanted to remind everyone on the call of Dassault Systèmes' overall mining solution portfolio that addresses the needs of our customers across the full mining value chain. The Dassault Systèmes mining solutions have been divided into 3 portfolios shown here. The first is called Capital Facilities and Project Lifecycle Management, which focuses on the life cycle of major infrastructure of a mining project, such as a processing plant, and using industry solution experiences covers that infrastructure from design to construction to operations and finally decommissioning. The second, called Resource Lifecycle Management, covers the definition of the geological asset through to the creation of various extraction plants. Lastly, the third portfolio, Operations Lifecycle Management, takes us into the operation of the mining business, the scheduling and the execution of mining processes, transportation, and selling to end customers. As shown in this slide, today's topic will sit inside the Resource Lifecycle portfolio, where following the definition and modeling of the resource, we can now use the strategic mine planning solution to create a profitable and robust strategic mine plan for the extraction of that resource. With that introduction complete, now let's dive into the topic of today's webinar, Strategic Mine Planning for Underground Industry Solution Experience. This industry solution experience is used by an operating or prospective underground mine to produce a long-term or life of mine strategic plan, evaluating the profitability of the plan, but also tracking key schedule outputs such as resources required, extraction sequence, and finally the production of the underground mine in terms of tonnage and grade. As shown in the slide above, this industry solution experience is made up of 6 distinct business processes, which will be covered in depth in this webinar. The process begins with the assessment of potential or of an active project based on new data, usually an updated resource model. With that, we can then move through the 6 distinct business processes with the end goal of arriving at that strategic plan, which will guide or be the basis of a feasibility study, a life of mine plan, a go or no-go factoring in potential project ranking for a company. The first business process is called Define Objectives. In this business process, we will aggregate all data into a central location, the 3D Experience platform. This allows for the integration and interpretation of data from multiple data sources to ensure the key parameters are accurately defined. In this business process, we will also update predicted development, production rates, and historical data to define mining parameters used in stope optimization and scheduling. We will also establish a probability distribution that will be used to model the uncertainty of the uncontrolled variables of the solution set. Finally, we will use the 3D Experience platform to scour the internet for the latest news on emerging markets, politics, and metal forecast pricing. Let's now examine the video to see Define Objectives in action. The process begins by logging into the 3D Experience platform. Once inside, we can examine the overall project status and then begin by activating the task at hand, define objectives. Then we'll begin by analyzing relevant mining news, trends, and feeds. In this case, looking at potential impact of COVID-19, and in another track topic, looking at all relevant news related to copper projects. At that point, we can begin collaborating with colleagues on key decisions. In this case, using a user community or group to discuss which gold price should be used for the strategic mine plan. Then we can begin managing and updating relevant project data. In this case, we will begin by checking out a key parameter file and then beginning to update this with the potential values we will use for this strategic plan. In this case, analyzing the uncertainty of different inputs, such as stope heights and widths, as well as the metal price that will be used. This is where the uncertainty modeling of potential distribution of values comes into play in the process. At this stage, we've completed the define objectives task and moved the task to the done status. As we saw in the video, the define objectives lays the framework for the industry solution experience. This allows us to increase the accuracy and confidence in the inputs which we will then use throughout the strategic plan. We also have a greater understanding of historical data, since all data is centralized in the 3D Experience platform. This will allow us to reduce the amount of rework required and reduce the overall time to analyze the problem. The second business process is called Stope shape optimization. In this business process, we will perform a stochastic stope optimization using SERPAC's SSO tool, using objectives of the project and operational constraints. We will also evaluate multiple scenarios against KPIs to select a collection of potential stope configurations. Inside of these iterations, we will also incorporate uncertainty, particularly into economic parameters like metal price, mining cost, and processing cost. This will allow us to create a stope design that is robust to changing market conditions. Now let's examine a video where we see the stope shape optimization in action. The business process begins by logging into the 3D Experience platform. Here we'll begin by reviewing the current project status and activating the task. We'll then move to GEOVIA SERPAC, where we'll connect to the 3D Experience platform using SERPAC PowerBuy. This connection will allow us to check out or download any required data from the 3D Experience platform. We can then execute the SERPAC Stope Optimizer and begin entering relevant stope design parameters to produce a base case stope design. Here we'll see what that design looks like. These are the stopes that the SSO tool has deemed to be economic. Once that's complete, we can then check back into the 3D Experience platform key project data, and this includes uploading the newly created base case stope designs. This process ensures we're using the correct version of any file, and versioning allows for full control of the file's lifecycle, including rolling back to previous versions if necessary. Then we're going to open up the Process Composer application to simulate or iterate over many different potential stope configurations. This is the simulation loop where these iterations will be created. In order to create the thousands of runs, we will change key stope design criteria such as angles, dimensions, cutoff grades, pillar widths, any key factor that we used in the base case scenario. Design matrix shows us the different runs that we've set up with the different input values, and the responses is where we show what outputs we're going to be tracking for each run. Things like the stope's value, tonnage, grade, as well as statistics of the solution. As mentioned, there is uncertainty regarding the economic parameters. So here we'll use a Monte Carlo algorithm to vary key economic parameters such as the cost of mining, cost of processing, and the current metal price. Once we execute the simulation, we can then begin to use the results analytics application to look at the simulation results. Here we can go through the results by defining key objectives for what we're looking for in a potentially good solution. Inside the results analytics tools, there's many different visual styles, graphical styles, data styles to really analyze what are the key input parameters and how do the results group together. Are there trends? And identify which inputs had the largest impact on the key schedule metrics. At this stage, we want to begin isolating relevant runs that meet our base profitability requirements. Then we can begin analyzing these specific runs and filter them based on different profitability criteria. At this stage, we've determined the top stope configurations that will be progressed to the next business process for further evaluation. As we saw in the video, the stope shape optimization business process will allow us to produce a robust stope design. Inside of the process, we've also increased the value of stopes, increased the task transparency and reproducibility, and decreased greatly the time required to generate and analyze these scenarios. The next business process in strategic mine planning is called stability analysis. In this business process, we will perform a stability evaluation of the potential stope designs from the previous business process. We'll also incorporate uncertainty into the geomechanical or geotechnical parameters like UCS, structural set, and stress conditions. Once this is complete, we will be able to select the optimal stope configuration, one that meets all relevant KPIs around economic performance, but now also stability and safety. With that in mind, let's take a look at the video for stability analysis. This business process begins by logging into the 3D Experience platform, where the user will grab the task from their to-do list and place it into progress. Inside the task, they will find a description, instructions, as well as any deliverables or due date associated with the task. Now we will return to the Process Composer simulation tool to continue our analysis of potential stope designs. However, this time we will focus instead of economic parameters, but on stability parameters such as geomechanical variables. You can see we are setting up the H Barton, 3 sigmas, and UCS as potential variables for this iteration. Similar to economic parameters, there's a degree of uncertainty surrounding these stability parameters, and therefore we will use a Monte Carlo algorithm to model the uncertainty and set up a range of potential values to try. Here we are setting up the standard deviation and coefficient of variation to control the number of iterations. Once this is complete, we will iterate these different stability conditions over the potential stope designs from the previous process. As shown in the video, we will be tracking key schedule outputs to provide an idea of the safety and stability of a potential design. Once these iterations are executed, we will open the Results Analytics application to view the results. Within Results Analytics, we will begin to review the results and compare the stability of potential stope configurations. As shown in the video, we will use a variety of different graphical analysis tools to examine each key parameter and understand the relationship between different inputs and their impact on overall project KPIs. As we continue in our analysis, we will begin to rank potential solutions in terms of their stability. Next, we will save the simulation results to the 3D Experience platform and analyze our list of potential solutions from the previous business process and this stability business process, with the goal of selecting a final stope configuration that was highly ranked in both situations. The stope configuration selected will be the configuration that is used for all downstream scheduling. After watching the video, we now have a greater appreciation of the stability analysis process. This process increased the reliability of our decisions and allowed us to achieve a safer and more stable stope design. We saw using Process Composer allowed us to greatly reduce the time required to analyze a multitude of scenarios, while also reducing design rework, as our stopes are both economically performant but also operationally sound. The next business process in the strategic mine planning workflow is called strategic mine scheduling. In this process, we will begin with the 3D design of the development network required to access the stopes designed in the previous process. With that done, we can then begin to schedule development, production, and auxiliary activities, such as backfilling, by setting up resources and defining an extraction plan using scheduling priorities and precedences. We can then begin to analyze different sequences or production rates to determine an optimal schedule that attains grade and material goals for the processing streams. Lastly, we can report out key schedule outputs, such as costs, development meters, grade, and tonnage from the production stopes. With that summary complete, we can now look at a video to see strategic mine scheduling in action. This business process begins by logging into the 3D Experience platform. Here we will begin by activating the task in question, Strategic Mine Schedule. Each task contains relevant information, such as the duration, instructions for the assignees, and it is also here we can add colleagues to perhaps assist us with this task. As an end user, I can also consult the overall project status, looking at the tasks that have already been completed, where we are on the path to project completion, and what tasks remain to be completed. Next, we will open up GEOVIA SURPAC and connect to the 3D Experience platform using the SURPAC Power By tool. By logging in and connecting, this will give us the opportunity to use relevant project data from the secured and managed 3D platform. Here we'll begin by checking out or downloading relevant data, such as the previously created Stopes, existing development network, block model, any relevant project data to scheduling. You see on the screen here the finalized Stope design from the previous business process. Next, we will use the Mine Designer role to create a development network required to access Stopes. This will include all ramps, shafts, and ventilation raises required to access the production areas. With that complete, we can now open GEOVIA Mineshed. This application is also connected to the 3D Experience platform using Mineshed Power By. So once again, we will log in to connect the authoring tool to the 3D Experience platform. Using the tactical mine planning role, we will create an underground mine schedule by sequencing both the development, production stopes, auxiliary activities such as backfilling to create an operational and feasible mine schedule. Once this is executed, we can use the dashboarding available inside of Mineshed to examine our schedule's progress, including animations, charting, as well as Gantt charts. This is the cockpit for the end user, and the results will also be available inside the 3D Experience platform. Although not shown in this video, Mineshed can also be connected to Process Composer, allowing the user to iterate different production rates and mining sequences. Please consult the Tactical Mine Planning videos for more information on this topic. To share these results with a wider community, we will upload the key schedule outputs to the 3D Experience platform. This will include the schedule animations, necessary charts, as well as key custom reports we've built where we track key schedule outputs. With this, we can complete the strategic mine schedule task and progress the project. After watching the video of strategic mine schedule business process, we have seen how this process allows us to maximize the schedule's value while also increasing the operational feasibility of the plan. The rich visualization inside of both Mineshed and the 3D Experience platform allows us to truly understand our underground mining sequence, while also reducing the time required to analyze alternate options and potential what-if scenarios. The next business process in strategic mine planning is called Prepare Financial Model. With our schedule completed in the previous business process, we can use Prepare Financial Model to forecast future production tons and grades with monthly, quarterly, and yearly plans. This allows us to report tons, grades, and materials through life of mine using Dassault Systèmes analytics engine. Finally, this creates different financial models, budgets, and reports for relevant project stakeholders. The benefit of this business process is that it increases the transparency and accuracy of the results, while also increasing the ability to collaborate with key stakeholders. This improved transparency also allows for greater visual identification of issues within the scenario, and the full analytics package allows us to more easily compare potential solutions, reducing the time to analyze these alternatives. The screenshot on the right-hand side shows how the outputs of the analytics tool can be integrated into dashboards for greater communication and collaboration of key schedule insights with relevant stakeholders. The final business process inside of strategic mine planning is share and collaborate. This process allows us to share and collaborate data using the 3D Experience platform across multiple departments and to key stakeholders. Dashboards will be used to illustrate key schedule KPIs, allowing for the easy visualization of the current mine plan with all relevant stakeholders. This will allow the user to quickly evaluate and interrogate historical data to ensure the plan is accurate and achievable. Let's take a look at a video to understand share and collaborate. We begin by logging into the 3D Experience platform. Next, we will grab the task at hand, share and collaborate, and move it into the In Progress menu. We can also review the current state of the project as a whole. Then we will begin using the 3D Experience platform to discuss the SMP results. A main focus of this will be using Dashboard to visualize key schedule outputs. This could be numeric data, such as the breakdown by year of key metrics of the schedule, like drill meters, volume, mass. This data can also be represented graphically so we can understand potential schedule issues as well as overall trends in our schedule's performance. Graphical data, such as the 3D stopes, can also be displayed inside of the dashboard, which allows any stakeholder to access the data and visualize it without needing to understand how the detailed design program works. Other annotation tools such as sectioning also exist, as shown on the screen. Finally, we can collaborate with team members around potential issues. In this case, the engineer has highlighted a potential issue with the stope configuration, and we'll look to discuss this potential issues with colleagues. This discussion stays inside the 3D Experience platform, combining data with all relevant communications as other team members weigh in on the issue raised. Now the user will provisionally complete the task while awaiting final approval from the manager. In this case, the task cannot be completed until the manager has explicitly approved the task. Therefore, the manager will log in, review the task, review the dashboards, and approve the task to be completed. At the end of the process, we may also wish to change the status of key scheduled documents. In this case, the main financial output of the schedule is being promoted from in work to released so that a larger community can access and view the data. After watching the video, we can now understand the value of share and collaborate, in that it improves collaboration between departments and allows for greater stakeholder and executive understanding. These two items combined will give everyone involved a greater confidence in the strategic mine plan that will be executed in the coming years. In conclusion, I just wanted to return to the full process overview. As we saw during the webinar, the combination of GEOVIA's underground strategic mine planning tools with the 3D Experience platform creates a very powerful solution with end-to-end simulation, governance, and collaboration of the strategic mine planning process. Thank you very much.